Now for example 3, right, I shall not do the whole of the question. I will just emphasize the similarity between this example and the previous example, and I want you to follow through with it. Okay, now again, read the question very carefully, find the clue, okay, and find what are the 3 variables that are related. Okay, now here they say that there is a cylinder here with a hemisphere on top and there's no overlap. That means the radius of the cylinder and the radius of the hemisphere, they are equal, they all are. Okay, and the total volume is 1215. Okay, so in this question, right, okay, if I look at the volume 1215, R and H, so there are 3 variables that are in play here, V, H and R. Okay, I want to make in part 1 H to be the subject in terms of R. Okay, so I know that for part 1, right, 1215 pi will be equals to the volume. The volume should be 2 parts. Okay, the cylinder will be pi R square H, and the hemisphere, right, should be 2 pi R cube over 3. Okay, how do I get this? Remember, for sphere is this formula. So hemisphere, half of it, you divide by 2, you're going to get 2 pi R cube over 3. Okay, now you notice that pi is common throughout, so I can remove the pi. Oops, sorry. Okay, I can remove the pi. This is R square H, and this is going to be 2R cube over 3. And this is the only term having H, so I make this the on the left. Okay, I will get 1215 minus 2R cube over 3. So H will be 1215 over R square. And I divide by R square, it cancel off, I will get 2R over 3. That's it. Okay, I've shown. Now, this is part 1. Part 2, again, okay, if I want to find the surface area, the total surface area, okay, it consists of 3 parts. The bottom part, okay, I call it, let's say, A1. Sorry, and then the curved surface, A2, and then the curved surface of the hemisphere, A3. Now you must know all your formulas very well. So A1, right? A1 is basically pi R squared. A2 is the circumference, which is 2 pi R times H. And then lastly is the hemisphere curved surface. The curved surface of the hemisphere. If you take note that the curved surface of the hemisphere is 4 pi R squared, so half of it will be 2 pi R squared. Okay, I will know that this is going to be 3 pi R squared plus 2 pi R H. Okay, now, but you want your, in part 2, the A to be in terms of R only. So you got to replace the H, right, found in this second term here with this. And you should be able to proceed to get this. Okay, now, so you understand the how to do such question. They always have 3 variables that are interconnected, or they are related to one another, and they want to make A, for instance, A here, right, to be in terms of R only. There's no H. Okay, so you have to actually use the clue. The clue is here. Okay, and then you proceed. Now in part 3, right, you got to find the value of R for which A has a stationary value. That means again, dA dr must be equals to 0. Okay, so you have to find dA dr, and then you got to set this dA dr to become 0 to find this stationary value of R that makes A a minimum. And again, how to know that A is minimum? You got to show, am I right? either the first or derivative test. Remember, choose the most efficient method. And lastly, again, similar from the previous example, find this minimum value of A, use this. Okay.